Okay, welcome back to the next section. Today I will carry on with the hardware, and this time it will be the Raspberry Pi. I think an amazing device. To think for $35 what you can buy. Okay, this is some of the topics I'll be covering in this section. Just a rough draft of what's going to be, what I'll show. Right, here is the Raspberry Pi from the top. This is a Pi 3B Plus. I think by and large with this course you could use a B, a B Plus, even a Raspberry Pi 4, but really go for a Raspberry Pi Zero, mainly because of the Docker. Needs a little bit more memory and a bit more horsepower, and as well as I find that Pi Zero with not having built-in Ethernet socket as well as proper USBs, it's a bit of a challenge of adding connectors and adapters and stuff. So alright, these are the specs. You've got a quad-core Broadcom chip, 1 GB of RAM, wireless LAN, Bluetooth, low energy, 100 base Ethernet, 40 pin expander GPIO header, 4 USB 2 ports, a 4-pole stereo input and composite video output, and a full-size HDMI that you can connect to a monitor. Alright, here is quite a nice drawing of how the board is laid out. You can see here's the Bluetooth, the Broadcom chip, the display connector. You can put an external display. I'll show in the next slides. Your connector for your 5-volt power supply, HDMI, the camera interface. Again, a flexible strip. You can have your own camera. You can plug USB webcams into here as well if you want to. Again, Ethernet jack, 4 USB ports, and then your 40 pin header, which allows you to expand it. Okay, here's again a bit more of a graphical display of all the bits and pieces. Yeah, okay. This is a block diagram. Once again, you can see the big brother, or the big boy, is the BCM, a system on a chip. You have these are the TFT display, and this is the camera, your HDMI out, 5-volt from a USB adapter. You then have your audio in and out, Ethernet, your 4 USB ports, 1 gig of DDR RAM, and of course this LAN 9514 is actually a USB and an Ethernet hub in one chip. Okay, and this is the amazing heart of the whole system. This is a system on chip, Broadcom. All the different Pis sort of have different iterations of the same chip. Obviously with more cores, more horsepower, so that's the amazing thing about the Raspberry Pis. This is what you'll need to get started. Obviously your USB power supply must be able to supply about 3 amps. This is a SD card, usually 16 gig I'd say is about the least you should go. A pretty fast one. You'd want, because of the amount of throughput and speed that's needed from the SD card. Okay, here's your hardware connectivity. This is this LAN 9514 chip that gives you your 4 USBs and your Ethernet. You can see this is essentially a block diagram of what's inside. Pretty amazing, just a piece of silicone can do all of this. This is your again your connectivity. Your Wi-Fi and Bluetooth is under this little module. You can see over here is the actual antenna. Pretty again, if you want to have a standalone system, and not want to connect the Ethernet, you can use the Wi-Fi. You just tend to find that from power consumption, I think that's where more of the power comes, is from the Wi-Fi and the Bluetooth. And this is Bluetooth low energy as well, so it allows you to do, you could have connect sensors to it, and so. Alright, here's a bit of an internal of an SD card. Obviously the SD stands for secure digital. The funny part about it is that very few people use the actual secure digital part. Most of it is just a sort of an SPI bus, which I covered in one of the previous sections on the SPI. You can recognize here as your chip select, master out, slave in, master in, slave out in your clock, and effectively through that SPI you issue commands, and you can read and write to the blocks of the flash memory. Here's a bit more of a description of the actual pins. Obviously this is a micro, but you obviously get minis and the normal large sort of old SD card, the full size SD card. Okay, here is your camera interface, as I mentioned before. So this is a flexible header. You actually get all different types of cameras with infrared and non-infrared, and I've seen they've released a very high quality CCD camera with quite a smart lens and everything, so you can actually get into some serious photography if you wanted to. Okay, here's your display. This is the display header, again with another flexible strip. In this case it's a full 7-inch touch screen. Obviously I think that there is an interface board that allows all of the circuitry to be interfaced between the Raspberry Pi and this actual touch screen, and but this is the actual display header here. Okay, here is a breakdown of the actual pins on the 40-pin header. I've seen in many cases people don't use all 40 pins, so you'll notice you have your power on this side, you've got your 3 volts, your 5 volts ground, and then you tend to find there are a number of grounds all over the place. So if you would like to, what I've seen people do, if you want to use, for instance, the other UARTs over here, and then here's your I2C, you tend to find the SPIs around the middle. So I've actually seen people make a little board that sits over here. So there you got your 3.3 volt, there you got your ground, and there you got all your SPI pins. These 2 pins here, they're called I2C. It's an ID. So what happens on a hat, you'll see in the on a later slide, you can get hats that plug in, and on the hat is a little E² prom, and these 2 pins interface with that E². So when the hat gets plugged in, the Raspberry Pi knows what type of hat is connected, and obviously can then load the right drivers or know how to interface with the hat. Alright, and here is again 2 examples. There are a lot of these add-on boards, or they call them hats. You can see as a motor controller, and then this is a relay driver. Obviously they've got decoupling here. Alright, well that's that for the hardware from the Raspberry Pi's point of view. In the next section I'll cover a little bit more about the actual router, because you're going to need a router to handle both the Wi-Fi as well as the comms to the Raspberry Pi, so that is going to be your network hub. So I'll cover that in the next section.